Hi, everyone. Welcome to day 3 of NCH MainTRAIN webinar series entitled Achieving Goals with Innovative Cooling Water Technologies. My name is Rochelle Mendoza, and I am with NCH Camaqua as Technical Specialist and Marketing Manager. I will be your host and moderator for this webinar. But first, I would like to thank you for taking your time out to join us today. Before we get started, let me go through a few housekeeping items so you know how to participate in this event. We have taken a screenshot of the attenders page. Since we do have a large numbers of audiences online, everyone will be muted throughout the webinar. You have the opportunity to ask questions or send comments through typing in your questions using the question box of the control panel anytime during the presentation of our panelists. We are going to collect this and address them during the Q&A session at the end of the presentation. And also, as a reminder, this webinar would be available for on-demand viewing on our website. So moving forward, let me introduce you to our presenter for this event. He is Manish Chawla. He is our Regional Camaqua Director for NCH APAC region. Manish has over 27 years experience in water treatment industry. In this industry, his career has spanned various roles in reputed global organizations in India and other countries in Asia Pacific region. He holds a Bachelor of Technology degree in Mechanical Engineering from NIT Raipur and postgraduate diploma in Business Management from IMT Ghaziabad. Hi, Manish. The floor is all yours.
Thanks, Rochelle. Hello, everyone. This is Manish with NCH Camaqua. I would like to first of all thank you all people for taking time out for this particular session. As you see here, the topic of today's discussion is achieving goals with innovative cooling water technologies. So before we get started, let me just clarify or explain what do I mean by the word goals. So, look, when I see the audience, I see people from many different industries right now. Some of you are from food and beverage, some from plastics, some from hospitality. Now, whatever industry we are from, I think most of you would agree that at the very high level, we have very similar kind of goals, right? We want to grow revenue for our organizations and gain market share. We want profitability and viability for our businesses. We want our businesses to be environmentally sustainable. Yeah, COVID-19 pandemic times have taught us we need to have business continuity in place. And on top of all this, we want to protect our brands and in fact grow them. So when I use the word goals, these are the high level objectives basically which I'm referring to. Now the question is, does water treatment have a role to play in achievement of these goals? The answer is yes. Because whenever we have got an effective water treatment, it helps us ensure a safe and reliable operation. It helps us reduce the downtime, cut down the production losses, minimize energy water maintenance costs, the OPEX costs, and of course, the CAPEX cost reduction as well, right? So that we don't have to prematurely replace the assets which we have. Labor productivity, minimizing liability concerns, and of course, an effective water treatment helps us meet all the regulatory requirements which we have. You know, it has been always important, water treatment in general, right? It was always there. But thing is, in the current times, it has become even more critical. In the current time, because of MCOs or circuit breaker or lockdowns, whatever we call it, you know, we are required to very frequently start and stop our systems. Now, when we stop our systems, what happens? We will have stagnancy related problems. There will be a lot of corrosion in the water systems. There could be a lot of microbiological growth. And now whenever we are operating, because our business have got high volatility in the demand, we have to keep on changing the operating loads of our systems. And on top of all this, you know, we don't have we are not able to provide our system so much physical attention which we generally do because of various restrictions in place, right? So in the end, goals when I'm trying to say is, hey, water treatment can help us improve the asset integrity, improve the efficiency of our systems, and reduce our total operating costs. In this way, we can achieve those high level goals which I mentioned. Okay, so first let us just briefly discuss in the first place why we need to treat cooling water, because water has got a lot of impurities, all kinds of waters, right? Water is a universal solvent. It will try to dissolve everything what it gets in contact with. And then we have, you see the hydrological cycle here, some part of the water evaporating, forming clouds, then leading to rain, then rainwater coming into rivers, reservoirs, oceans, and some part of this water going down into the earth and dissolving some impurities like calcium, magnesium. So because of this hydrological cycle, water gets a lot of contact time with earth and other matter. So first thing, first impurity because of this, what we call is a dissolved solids. For example, if I take a glass of water, put a spoon of table salt in it, shake it, after some time, I don't see it because it got dissolved. Same way, water have got maybe hundreds different kinds of salts dissolved in it, which we say by the term TDS, total dissolved solids, or conductivity. Same way, we've got a lot of dissolved gases. Every water will have, I mean, mostly water will have oxygen. There will be some carbon dioxide. Sometimes uh, when the vegetation is decaying here in the earth, we might have hydrogen sulfide coming there. So all kinds of different gases, right? And the third kind of impurity is suspended solid, something which is not dissolved, which is floating in the water. It's suspended, right? Like mud, silt, sand, even bacteria, right? Now, because we're talking about cooling systems, I have just for an illustration shown here, the cooling systems can have open circuit and can have a closed circuit, right? So, for example, in this particular diagram, what you see, there is a cooling tower here, which is catering to the condenser of your chiller. So, cooling tower water is going in here, going into the condenser, taking the heat from the hot refrigerant gas, and cooling that refrigerant gas. But in that process, it is getting hot and coming back to the cooling tower and then gets cooled in the cooling tower. So, this is the open circuit. At the same time, we might have a closed circuit, your chilled water going from the evaporator or cooler of your condenser going to your HU and coming back. Now the point is the impurities which I mentioned in open systems, they will tend to concentrate. Why? Because how is the cooling taking place in the open cooling water system, in the cooling tower? It is by evaporation, right? So when water evaporates, it takes the latent heat of vaporization. So remaining part of the water gets cooler. But now one thing happens here. Whenever water evaporates, only pure water vapor goes into the atmosphere. No salts can go with it. So what will happen? Those salts will keep on getting concentrated in the water which is left behind. It is something very similar to, say, if you put water in the kettle here and evaporate it to dryness, whatever salts were there in this water, they will tend to remain behind. So something very similar is happening in the cooling tower. Now, more impurities because of concentration, we might have more problems. So, what do? We give some blowdown. We take some part of this water, this concentrated water, throw it out. But as the water evaporates, some water lost because of that, some part of water lost because of the blowdown, the level in the cooling tower will tend to fall. So, what do? We put up less concentrated, make a water back in the cooling tower. Now, whole of this process of concentration, we sometimes use the word called as cycles of concentration, right? It is nothing. Basically, what it means is if you have a makeup water of 100 TDS, and if your cooling tower water, when you test, and if you find the TDS is say 400, so 400 divided by 100 means 4, means the TDS or the salts got concentrated by 4 times. That is what we call as cycle of concentration. It will depend on the ratio of the makeup water rate divided by how much blowdown you gave. More blowdown you'll give means more concentrated water goes out, right? The concentration will fall, cycle of concentration will come down. But more blowdown you give, more loss of water, more loss of chemicals which are there in the water, and the other way around. If you give less blowdown, the cycle of concentration will increase. Now, all these impurities which I spoke about, those three impurities and this concentration mechanism in the cooling water will lead to basically four kinds of problems: corrosion, fouling, scaling, and microbiological growth. Just see the arrows here. They can lead to one, can lead to the other, right? And we'll discuss more about this correlation or this relation amongst each other later. But let us just briefly see what these four problems are. Scaling. So scaling is basically a hard tenacious mineral deposit which is formed at the heat transfer surface. So when the concentrated cooling tower water comes to a hot surface, like say it could be a surface of condenser in your chiller, it could be a heat exchanger, any kind of heat exchanger surface. The skin temperatures are high, there is a lot of heat. This this water having more TDS and especially salts like calcium and carbonate, it cannot remain soluble. Its solubility will be exceeded. So it will precipitate out and form a layer like this. Can you see here? So this is what we call it as scaling. Now, is it good or bad? It is bad. Why? Because the scale is a poor conductor of heat. Heat cannot transfer through it. Now this heat exchanger was made to transfer the heat, but thing is, once the scale forms, it cannot do the job for which it was designed for. So the overall heat transfer efficiency will fall. So whatever we call it, the overall heat transfer coefficient or whatever, that will reduce. In the end, what it means to us? Higher energy cost, right? So for example, let us take an example of a 200-ton chiller cooling tower. As the thickness of the scale keeps on increasing, like say from 0.01 to 0.04 inches, which means very less, you see the electricity bill keeps on climbing up. Maybe for 0.04 inches, even in 200-ton cooling tower would mean 400,000 US extra in the electricity, right? So it costs us a lot of electricity. Corrosion. What is corrosion? Corrosion is an electrochemical process because of which the metals, because of which there is a loss of metal, right? Whenever there is a water which has got TDS and oxygen and it comes in contact with any metal, it will try to dissolve that metal back. And that is why this loss of metal. Now, this loss of metal could be uniformly across all the parts of this, right? More or less same kind of loss taking place from all the surface, or it could be localized, right? And when this localized, if it is localized and if it is form of holes, we call it pitting, right? In the end, all this would mean reduced equipment life. We might have to replace the equipment much before its design life. There might be sudden failures, right? Sudden leakages, and we might have to take unscheduled shutdowns, so production downtime. And all this iron oxide, which is coming because of corrosion, will go and settle elsewhere. Now, this also has got lower thermal conductivity. It reduces the heat transfer. The third problem is microbiology. Look, every water will have some kind of living microorganisms. Maybe our drinking water even has. It can have some bacteria, some waters will have algal cells, fungi. Now, till the time they are within the limit in that water, it is fine. But once they grow beyond a certain limit, beyond the allowable limit, they start creating problem. So thing is, now why do they grow in the cooling tower so fast and so much? The thing is, the cooling tower has all kind of environment which actually supports the microbiological growth. These living things need what? They need nutrition. They need non-harsh conditions. I mean, temperature and pH should be conducive. They need a lot of air. Maybe some of these algal cells need sunlight. They have everything in plenty, so they grow a lot. They tend to grow a lot, and they grow rapidly because they follow a geometric progression. So what does it lead to? It can lead to heat transfer efficiency loss. Why? It is even, I mean, the thermal conductivity of a biofilm or this microbiological slime is even less than that of a scale. So it will stop the heat transfer even more. So it will lead to higher energy cost. We might have to take shutdown, clean the heat exchangers, high maintenance cost because of leakages like this. Like see here, this is a leakage because of microbiological fouling. And then we can have problems like Legionella, human health problems, right? People fall sick with pneumonia. Fouling. So fouling is basically the fourth problem is it is like a loose deposit. It is not a scale. It is not a hard tenacious. If we scrape it through, it might come out. So it is a build-up. It is a accumulation. Now accumulation of what? It could be mm, it could be mud. It could be silt. It could be even corrosion products which are being formed in the system right now. It could be scale chips. It could be algae, right? So it can be from within the system. It can be from makeup water or from the air outside. So what will this lead to? It will reduce water flows and hence reduce the heat transfer efficiency. This becomes a great place to start having localized corrosion here, right? It will lead to more microbiological growth because bacteria get a lot of place to relatively enjoy and grow, and then more operational costs. So now, how do we know whether our systems, our systems in our facilities or plant do really have any or most of these problems? How do we know that? Let me give you some examples from which you know, hey, do I have this problem? Now, I've taken examples of some common cooling water equipment which we generally use in our facilities. So, one thing is chillers, the water cooled chillers. So if you find you have an electricity bill which is rising, even if the cooling load remains the same, you have a problem. Or you're not able to achieve your chill water set point. Or your condenser approach increases very fast. Maybe 1 year from 1 degree Celsius, it increases to three, right? Your kilowatt per ton if you are monitoring that, or if you have to open and clean the condenser very frequently. And when you open, you don't find pure copper color here, you find some deposit, some scale maybe here in this photograph, right? So there could be air compressors. So if you find any air compressors, high electricity bills, or what we say intercooler temperature, interstage gas temperature, if it goes too high, or oil temperature goes high, or compressor starts tripping because of high temperatures, or you need to open and descale it, right? So all these things would indicate, yeah, maybe you have one or more of these problems. If you have some plastic molding plants, plastic molding machines, yeah, if your molding machine trips, high oil temperature, or in your molds, it was designed for 10-second cycle time, but it becomes 11 now. Yeah, you're losing production. Or when you open up the molds, there is a lot of rusty brown water coming out, right? So oil temperature, cycle time, or if you start finding the rotometers getting fouled here, or your temperature controllers, they're having these kinds of scaling or problems, right? So this would another indication. If you've got spot welding, for example, and if you have some spot welding guns with these electrode tips or water cooled transformer cables, and you find some scale deposit or this greenish copper oxide corrosion product, right? You have to replace, you have to clean this. Maybe once in every week you have to descale it, or maybe it was supposed to last for maybe say two months, or say 3 months, but you have to replace after 1 month. This is all capital cost. So this is like copper corrosion. It will look something like this. Cooling water piping, if you find things like this, maybe the piping was designed for 30 years, but hey, you have to replace it after 10 years. Why? Because you have a deposit like this, or you start finding it is leaking for different places, or you need to flush it. And same way for the heat exchangers. Cooling towers, if you find you have to clean the cooling towers very frequently, or if you start finding, hey, in the spray nozzles, I have got a lot of this fouling matter here, right? Or you find a lot of algae or scale deposits here inside the fills, and you have to replace the fills maybe after 5 years. Hey, this fills should have lasted for 10 years. So look, these are a few examples for you just to know and find out, hey, do I really have any kind of this problem? So whenever you find, yeah, there is this kind of a problem, yeah, there could be other reasons, but generally it is poor cooling water treatment. Okay, so now we have had this problem, not only now, it has been there forever, right? These kinds of four problems. So what have we been doing last, say, 5, 10, 15, 20 years or last 2, 3 decades? What was our traditional approach to address these problems? Yeah, so what we do is generally what we have been doing is we will collect the system details, collect the mechanical operational aspects like what are the flows, maximum temperature, skin temperature, bulk water temperatures, hey, what metallurgies we use, do we have coatings, do we have filtration. So we'll collect all these kinds of details of the system, and then There would be a water treatment chemical company which would design a treatment program. It will design, hey, how much makeup, blow down, what should be the cycle of concentration, and then will decide, hey, what chemicals to use. So chemicals to stop scaling, scale inhibitors. Chemicals to stop corrosion, corrosion inhibitors. And then say dispersants for mud and all. And biocides to kill the microbiological growth, right? So like for example, like this is example I put for, if there is a corrosion inhibitor, like this is with good corrosion inhibitor, you don't have any corrosion. When the chemical added, if it is not good or not enough added or not working, you will have corrosion. And this would reflect something like this in your pipes in the plant when you actually see them. So after we design a treatment program, we try to apply it. So what we will do, we will have somebody coming and testing your water maybe every week, every month, whatever predetermined frequency is. He will do the chemical analysis, he will do dip slide test for microbiology, then collect all that data and make trend charts. And then how to manage it, so that if they are breaching certain limits, he will make manual adjustments to the blowdowns or to the chemical feed rates. Sometimes last 10 15 years, yeah, we have some more automatic controls. We might put some basic controllers or try to control them. And then after we have been doing this for months, we will keep on monitoring our chiller data, our air compressor data, our spot welding machines, physical inspections or the temperatures, and we try to validate. So this is what we have been actually doing for last few decades. Now thing is, if we have been doing this, if I still walk into plants, we still see those kind of problems which I showed you. Then why do they happen if we have been doing all this correctly already? Now, there are some few common reasons. First of all, of course, you need good chemicals to stop scaling, corrosion, and fouling. But thing is, even if you have a good chemical which can control maybe three of these four, it will still not work. Why? Because these four problems are all interrelated. These arrows which you see, one can cause the other. Scaling can cause corrosion, corrosion can fouling, and then they can coexist with each other. If you see this condenser tube, for example, hey, what is this? Is this scale? Yeah, looks white, yellowish white, looks like scale. Hey, but it also looks slippery. Hey, maybe there is some slime also, bacteria also in it, right? So this is one challenge. If we don't have a treatment program which address all the four at the same time, it won't work. And that has been sometimes the case. Now, too many parameters. Look, every chemical treatment program, every chemicals will have certain limits. And there can be many things: pH, conductivity, hardness, silica, sulfate, chloride, iron, so many things. So there are too many variables and too many parameters to control. Some we can measure, some we cannot. Some we can control reliably, some we cannot. But for good results, we need all parameters need to be controlled correctly within the chemical treatment program limits at all the times. It is necessary. Then we were talking about the evaporation in the cooling towers. Hey, it's a highly dynamic system. The evaporation rate changes all the time. We said, hey, evaporation rate will decide how much blowdown we have to give, how much makeup we have to add in addition to the makeup water quality. But thing is, the evaporation rate itself keeps on changing so frequently. In summer system, it would be different. In winters, it would be further different. Hey, maybe in the morning it would be different. In the night it would be different. So it will depend on the ambient weather conditions, the relative humidity, the diurnal temperature. It will depend on your plant load. Like in COVID-19 time, sometimes you operate 50%, sometimes you operate 100%. Evaporation rate will keep on changing. But thing is, when the evaporation, and we cannot control it. So when evaporation rate keeps on changing, we need to be controlling the blowdown. Now, if it is changing from morning till night, that means somebody has to sit down there and keep on controlling the blowdown if we want good results. Now, with the changing blowdown, yeah, chemical addition has to be changed. So these are highly dynamic systems, very difficult to control manually. Then many of the variables will conflict or compete with each other. Just see, if the cycle of concentration goes up, if we give less blowdown, the TDS goes up, the scaling tendency will increase, the solubility will reduce. But if we run it at low cycles, if we give too much blowdown, the water will become corrosive. In the same loop, your supply header temperature might be lower, return header temperature is higher, so the tendency will be different, right? if you talk about, like, say, let us take example of velocity. If heat exchanger was designed for some velocity, if we go higher than that, we can have more corrosion, more oxygen going there to corrode, right? There could be some erosion. If we keep low velocity, the the salts get more time to settle down or to precipitate on the hot surface. So scaling turn. So see, different variables, too many variables, it's like juggling too many balls. But thing is, while we are juggling with too many balls, there are a lot of conflicts, a lot of competition. So these have been certain reasons because of which actually generally it has been very difficult for us to get all the time good results in spite of doing whatever best we did. We had a good intent, but we always don't get the good outcome. So now question is, do we now have some technology which can help us address these challenges so that we can still achieve our high level objectives of profitability, sustainability, and all that? Yeah, it's an old saying, necessity is the mother of invention. So now we do have certain innovative technologies which can help us. I'm going to touch a few by NCH, right? So I'm going to talk about Aquadart, which is a monitoring and control automation package. I'll be talking about Handycam, which is a more sustainable chemical treatment solution. I'll be talking about BioDart, which is breakthrough biomonitoring tool. So let us start with Aquadart. So Aquadart is basically, and like I said, an automation and control system, and it is based on fluorescent technology. What does it do?
Without proper control, cooling tower systems experience a variety of problems. Scale reduces heat transfer efficiency and can lead to system downtime. Corrosion shortens equipment life and may result in unexpected failures. Microbiological growth reduces heat transfer, increases corrosion, and can lead to pathogenic hazards such as Legionella bacteria. Inefficient water use means paying for increased water demand and wastewater generation. All these potential problems increase the total cost of operation for a cooling tower system. ChemAqua's Aquadart water treatment control system is state-of-the-art automation for water treatment programs. Aquadart offers real-time monitoring and control to minimize the impact of scale, corrosion, microbiological growth, and water usage with quantifiable results to help protect your cooling system. Scale and corrosion control is monitored with fluorescent traced cooling tower inhibitor products. Aquadart's fluorometer directly measures and maintains the proper level of inhibitor in the system. Microbiological control is maintained and monitored using custom ORP link timers to ensure proper biocide dosages. Water usage is minimized using connectivity control to ensure proper cycles of concentration and blowdown rates are maintained. Aquadart provides online feed and control verification of vital system chemistries to minimize water-related problems and inefficiencies. Wireless and direct connection to the cloud allows remote system monitoring and call-out alarms for upset conditions. When treatment levels are out of range, chemical pumps stop pumping, chemical drums run dry, blowdown valves malfunction, and more, Aquadart triggers alarms for immediate notification and rapid response. Aquadart's automation can improve labor utilization, freeing up personnel to work on other important tasks with the peace of mind the cooling tower system is under control. Compared to other advanced water treatment control systems, the open source design allows Aquadart owners long-term use of this valuable asset. ChemAqua's Aquadart uses fluorescent trace technology to deliver real-time, performance-based feedback and control for cooling water systems. Aquadart systems enable high-performance water treatment programs that provide improved results and reduced operating costs.
Now, like I said, there can be many things. Do we every time need everything? Maybe not, right? So in the end, we need to have a system which helps us monitor what is important for your system, depending on what your system is and depending on the make of water quality and other factors. In the end, we want return on investment. Whatever dollar you spend, you need to be able to get more returns out of that, right? More than the investment. So that is what is return on investment. So, I mean, wherever you have a requirement, please contact your Chemaco water treatment consultant. He can come and do a survey and say, yeah, this is what is needed for your system. This is what is not. So that you don't invest in something which you don't need. Now, let us add on to this, and let me add on the second part of the technology. What if we have aqueduct or we have a system, but we say, hey, we need more greener, eco-friendly, sustainable solution? What if you say, hey, I don't like chemicals. I don't like the safety aspects or handling problems related to chemicals. Hey, what happens to these empty drums? So many empty drums every month, cannot dispose it because it might be against the law and it's a hassle. Hey, I don't like this cooling water treatment dosing system and so much crap there, right? I don't have so much place. I want to improve the footprint. Or you might say, hey, I'm worried. I have a great automation system or great cooling water treatment program in place, but I'm worried in the night if the chemical runs out, what happens? Or maybe, say after 1 month, if it happened, everything falls apart. Yeah. So now there is a solution for that also. If you need more sustainable and more greener and more controls, yeah, we have got something called Handycam. Okay. So this is a solid chemical treatment program. What does it do?
Water treatment chemicals are necessary to prevent scale, corrosion, and microbiological growth in your cooling towers, boilers, and closed systems. Traditional water treatment programs typically use liquid chemicals in hard-to-handle drums. What if you could replace the heavy liquid drums with space-saving solid concentrates and a dissolving system? With ChemAqua's HandyChem solid water treatment solution, chemicals are provided as solid concentrates in block or 1-gallon plastic bottles, rather than liquids in drums for a simple, effective, environmentally responsible solution. The HandyFeed solid systems were designed for chemicals to be made on demand, eliminating the difficulty and frequency of adding or changing chemicals when treating larger systems. The HandyFeed Ultra B solid system allows up to 4 solid concentrates in block form. As the block level decreases, another block is added. The HandyFeed Ultra M solid system uses solid concentrates in 1-gallon recyclable plastic bottles. Once the bottle is empty, replace it with a full bottle. The old bottle can be rinsed and recycled for a more environmentally friendly solution. Solid concentrates come in 4 1-gallon bottles or blocks per case. The concentration of each case roughly equals 1 30-gallon drum of liquid chemical. The HandyFeed dissolvers make chemical feed solution on demand by spraying water at a constant pressure onto the solid concentrate, filling the reservoir beneath. As the sensor recognizes the reservoir is full, it automatically shuts off the flow of water. The feed solution can then be pumped into the system, just like with liquids. When the sensor recognizes the solution in the reservoir is low, it opens the flow of water, refilling with more solution. The HandyChem solid water treatment system can replace the traditional, drum-based water treatment program. The HandyChem system provides several benefits over liquids. Space-saving design. Eliminates drum storage and disposal. Reduces employee material handling concerns. Reduces spill and splash concerns. Easier delivery and installation. Plastic bottles can be recycled, reducing greenhouse gas emissions. ChemAqua is committed to providing environmentally responsible and economically viable water treatment solutions that conserve energy and water while protecting the health and welfare of people and the environment. The HandyChem solid water treatment solution is just one part of our Resourcefully Green initiative. The HandyChem solid water treatment solutions by ChemAqua is an innovative solution that provides the proven results of high-performance liquid treatment programs, but is easier to use and more environmentally responsible.
So basically now I'm going to take you or talk through the third technology, which we call as BioDart. Okay. Now, this is something very new and relatively recent, maybe last 1 or 2 years, but after a research of maybe a decade. Okay, so let me just quickly go through.
Biofilms can cause a wide range of problems in building water systems, including cooling towers, decorative fountains, and domestic water. Biofilms are a complex community of problem-causing microorganisms encapsulated in a protective coating, sometimes called slime. Biofilms form when free-floating bacteria in the bulk system water attach to surfaces such as pipe walls, shower heads, chillers, and basin walls. Unattached bacteria produce an extracellular polymeric substance or slime that holds the growing biofilm together. Biofilms are 90% water and very insulating when present on heat transfer surfaces. As biofilm matures, a complex community of microorganisms develop protected from biocide additions, including Legionella bacteria, and cause fouling. The number of bacteria in the bulk water do not correspond with the amount of biofilm. Microbiologically induced corrosion can occur underneath biofilms. In an advanced biofilm, higher life forms, such as amoeba and protozoa, ingest bacteria in the bulk water and biofilm. Some bacteria, such as Legionella, can multiply inside the higher life forms to the point of bursting the host organism. This can suddenly release high levels of Legionella into the bulk water. Biofilms can cause a variety of problems in water systems, including corrosion, fouling, reduced heat transfer, and contribute to Legionella growth. Effective biofilm control is key for safe, reliable, and efficient operation of water systems.
Biofilms are the root cause of serious and costly problems in cooling water systems. The BioDart Biofouling Monitor is new, cutting-edge technology that automatically monitors the potential for biofilm formation. BioDart provides valuable information that can be used to quantify and improve control measures and gives an early warning of upset conditions to address problems early. This information provides a sensitive, system-specific indicator of microbiological conditions that reflects the wide range of factors contributing to the potential to form biofilm. This innovative new technology can function as a standalone monitor, or it can be connected to a ChemAqua web-enabled AquaDart controller. Contact ChemAqua today for more information about the BioDart Biofouling Monitor.
So look, these are a few innovations which I showed you, which helps us address those kinds of problems which we didn't have solutions so far. So now we have ways by which we can make the cooling water treatment effective. Let us not forget, my guru has always told me, all bad or ineffective water treatment costs money, right? Effective water treatment is an investment. It will give you returns beyond the investment if somebody rightly designs and if you have the right tools. It is not a luxury. It is a necessity if we want to achieve those high-level objectives of profitability, market share growth, brand sustainability. So I would like to thank you all for all your attention and time today. So over to you, Rochelle.
Thank you, Manish, for the very informative presentation you just shared to us. Now, I am very excited to show everyone our NCH showroom to let our participants see the actual equipment, innovations that Manish have been sharing to us. Now, I give Naranyu the floor all the way from our Thailand showroom. Naranyu?
Thank you, Rochelle, to give me the chance to present our showroom. So let's follow me. I will show you our showroom here. In our showroom, you will see many products from each specialty of NCH, such as maintenance, lubricant, facility, life science, and food safety. But today, I will show you ChemAqua innovation. So yeah, let's move on this way. This is the water treatment system. It's a real-time control. So this one called AquaDart. I will show you the monitor will show you the necessary parameter that control your water quality, such as conductivity, pH, ORP, and also control the chemical feed, such as inhibitor. And our parameter here will link with the sensor. Sensor here is such as pH, ORP conductivity, and also chemical feed. And the system will have the flow rate check also. So I will show you one thing. This flow rate will show if the flow rate, the float is at the sensor, the flow will on, and if the float is not at the sensor, the flow will off. So it can check your system also. And moreover, it have an optional function. You can control this from the web page. I will show you the web page to control Aquadat system. Yeah. So from the first page, you will see a lot of Aquadat system here, but the system I will show you in our showroom is this one. Yeah. Okay. So now you can see the system show the graphic. Now the flow is off, as I show you. The flow is not at the sensor. So this one will show same as the monitor you just see, and you can see the chemical feed also, such as biocide program and our inhibitor program here. So now it's still off, and also it's linked with the monitor such as conductivity, temperature, pH, ORP. And moreover, you can control it online. I will show you how. Okay, I will turn on the pump of biocide. Now it's off. So I will turn it on and submit. Okay. So now you can see the pump is working as your order from the web page. So it can really easy for you. Everywhere you are in the world, you can control and connect with your staff team to control water treatment. Yeah. Okay, I will turn it on now. Okay, and also another function, and it can create report as the graph. So now I show you one graph from conductivity. Okay, as you can see the graph reading, because I just turned on, so it's not many data. So this data will make you control the cycle of water very accurate. Yes. Okay, another our innovation is solid program. As you see here, it's called Handycam. This one is very easy to load, as it's very light, only 5 kilograms, and it's eco-friendly because it eliminates the drum or pail you use, really heavy, and also eliminate the landfill waste also. And it's very effective because this 5 kilograms is equal 72 liters of liquid program. So yeah, very easy and friendly to use and safety, and compatible with our Aquadat. The last innovation that I would like to show you here is called BioDart. It is our new technology and is patented by NTH. It is just zoom in. Yeah. This is the monitoring potential for biofilm to form. It's confirm and improve efficiency of microbiological control. The leading in the BFI is instead of biofouling index. The reading full range is 0 to 7, but normal rate of this will show from 4 to 7 in 1 month. If the rate higher than this, 4 to 7 in 1 month or quicker, it means we need to review our biocide program. So it's really useful and warn us before the problem have really severe problem. So this is our technology that will support your system to save water and save energy consumption. Yes. So that's all, Rochelle.
Thank you very much, Naranyu, for the wonderful tour in our NCH Thailand showroom.
Yep.
So Oh, you're open for answer and question portion. Thank you very much for that wonderful tour, Neranyu. So, but before that, I would like to introduce also our Asia Pacific Engineering Director for Kemagwa, Mr. Long Cheng Lee, all the way from Singapore, together with Manish, our Regional Director, to help us answer all your questions. So before that, we will start those who have sent their questions in advance when they registered. So we start with Manish. How would you like to answer this question? How will NCH continue to provide services given the current situation? Has there been any changes compared before? Maybe he was referring to the COVID situation.
Yeah, like if you heard me speak earlier, that yes, I completely agree that the COVID-19 has challenged us and made us do things slightly differently. But what is that difference which has been created? The difference has been it needs more attention because, like I said, we have to frequently start and stop our systems. Sometimes the operating loads keep on changing. Uh, Now, how to provide that attention has been the challenge. And that is what, if we use some of these innovative technologies which I mentioned earlier, like aquadarts, like handycams, then even if we are physically not there, the attention can still be given. So I would say during this period, like I mentioned earlier, many of our customers benefited a lot because of these kinds of technologies like aquadarts, handycam being there already. Now, for all our new customers, wherever we think the systems are very critical and are going to face these changes and demands, we are recommending them to go in for such technologies which can be remotely monitored.
All right. Thank you, Manish. Okay, this is another question from Lukesh. How to maintain equipment with less staff?
Rochelle, let me answer this question. Yeah. I think this is a very good question. It's always a challenge to us. I think firstly, we want to say the prevention is better than the troubleshooting. So the water treatment purpose is to help our client to reduce the unnecessary shutdown or the extra maintenance. So this is very important to do the proper water treatment first. Secondly, as Manish mentioned, the automation and digitalization now become more and more important to support the maintenance team and reduce the frequency of the maintenance. And I think thirdly, NCH, we also can support from different sides, water treatment and other side like maintenance, like a facility. So this also combined together give you a better solution and less contact points to improve your efficiency. So that's what I can consider now. Maybe Manish, you have some additional ideas?
No, I think you already covered them well, LC. Basically, all these automations and whatever we are talking about, these control systems, yeah, they are meant for giving better results, but at the same time, they reduce your physical touch points, right? So, one of the objectives of all these systems is to reduce the operational costs, reduce the amount of attention which you need to physically give by deputing someone. And let us not forget that, hey, these are dynamic systems. Even if you have somebody sitting down there near the cooling tower and making changes all the time, they won't still work. So yes, all these systems would definitely address the reduction in the manpower costs.
Right. Thank you. I think that's a very good answer. We have another question here from the Philippines. Thus, all water treatment chemicals of NCH environmentally friendly? Is it acceptable by regulating body like DENR in the Philippines? From Izagani. So I think I can answer that question since I came from Philippines. all our chemicals are actually environmentally friendly. As you can see during the presentation, they have all necessary certification that can qualify, such as DNR or Department of Environmental and Resource in the Philippines. Anything else you want to add on?
Yeah, I think this is a very good question. I want to add on a little bit details about our company. So as a global company, we really following the regulation by global and also by different country. I can share a little bit details of our company, like we are working very closely with our product technical team. And country by country, the regulation really different. Some product is available in one country, multiple country may not in a certain country. So we really pay a lot of details for following this kind of requirements. So this is very serious for us.
And on top of
Alright.
that, while all these products are definitely, they meet all the local or regional pollution control board requirements before you discharge. At the same time, some of the technologies, because I mentioned about that handycam, right, that solid, they can reduce the load on the system before you discharge. Because look, when say 200 liters of liquid chemical, which might have caustic and other things, when it is shrunk into or concentrated into 5 kilo solid, all those things reduce, right? Those caustic and all. And that is why it makes even more greener. So for sure, all the products from NCH, they meet or exceed the local pollution control board requirements and have the necessary certifications, but they're even better, the technologies like solids.
All right, thank you, Manish. So next question would be come from Tony. What caused the growth of Legionella bacteria in the cooling tower? How to prevent it beside chemical treatment?
So let me take this. Look, Legionella bacteria, it has been there, not now, for last, the first outbreak, I think, was around 20, 25, 30 years ago. And like I was mentioning in one of my presentations on BioDart, which deals some little bit with microbiological control, these outbreaks have been once in a while, once in 4 or 5 years, in spite of whatever findings were, they were still happening. Now, how to control them? What we find is it's a mix of 3, 4 things, and not a single one of them would address it completely. So one thing is, of course, it's a bacteria. It's a living thing. If you use a biocide, it will kill that. So whatever other biocides might kill other bacteria, they might kill Legionella as well. But thing is, the question is, where does it grow and how does it grow? And if it suddenly starts growing like you were seeing in the higher life forms like amoeba, and they suddenly discharge too much Legionella in the water, is your microbiological control in place to know, yeah, there is sudden high load of Legionella bacteria in your system? So yeah, the second part, so after biocide, is then being able to monitor. And BioDart was one of the ways, potential ways by which you could know that. Third thing is, only by having chemicals, biocides, and having monitoring, will it actually help us eliminate the Legionella problem or feel very confident? Probably the answer is no. Uh, so these are good things, but in the end, it requires a good mechanical and operational control of the system. You would not like to, for example, clean the cooling towers regularly, because you don't want sludge and those kinds of things, which give a lot of opportunities for bacteria like Legionella to grow. You might like to have right velocities. You might like to have, like some countries like, say, for example, in Australia, from Singapore, they have laws for the disinfection, monthly disinfection. So it's a mix of all these things. So, and that is what this partnership is about. Because look, this can be done only when a chemical treatment company like us and you, we all partner together and solve it together, so that we can have good night of sleep, that yeah, we are not going to have some outbreak of Legionella. So long answer, but thing is, these are all the components which are needed. It's a good question. Thanks for that question.
Yeah, I want to add on a little bit more information. We know the Legionella test, it takes 10 to 14 days The first result come out on 10 days, and the final result come out on 14 days. So it's when we got the final result is passed already. So many things changed, and when the result gets positive, that's become a big headache. So what Manish introduced today, the BioDAT, this is what's really Camargo are focusing on is the microbiological control. So this one can help you to predict the system condition of the biofilm growing. So this can give you early signal to prevent the issues as much as possible. So hope this will be helpful for you as well.
All right, so I think we've got like three approach that we need to take care of, like what Manish was saying about not just only chemical, but we have also focused on mechanical and operational. So the next question would be like from Kanisha, can we operate a cooling tower with zero intentional blowdown, whereby the cycles are capped at about 12 due to windage loss? So Manish, would you like to answer that, or Elsie?
Yeah, look, theoretically, maybe yes. Practically, maybe yes, and maybe no. Depends on the system. If you see what I was mentioning, uh, how much blowdown we need to give is a function of two things. Uh, First of all, how much evaporation is there, which will again depend on the ambient weather conditions and your plant heat load. So if your plant heat load is less, evaporation will be less and less blowdown needed. So yeah, so we can reduce the blowdown there. At the same time, it depends on your maker water quality, right? How much TDS and other chemical species does it have? Uh, but your question is specific at 12 cycles of concentration. Can we minimize the intentional blowdown? Yes, it can be if your heat load in the system is less. But though we say intentional blowdown, but drift will be already there, right? There will be some loss of water physically happening because of the water droplets coming out. So yeah, but intentional blowdown can be reduced to a large degree. And if you are asking this question with reference to zero blowdown systems, yeah, there are different ways and means, mechanical and chemical put together, that can still be achieved. Yeah, it is being done in many countries, many places, and I've witnessed them for last 15 years.
Yeah, I think I can add on some comments as well, based on what Manish mentioned earlier for this presentation, the impurities in the system. So in recent days, more and more requests for zero blowdown. I think this is a very professional question, and even mentioned about 12 cycles. So technically, yes, it's possible. It's the only thing is how to control the impurities inside the system. So we have some applications with zero blowdown, but definitely there's no, it's not just as simple as close the valve of the blowdown, right? So you need additional design to remove or balance the impurities inside the system.
And that's right. Look, once we stop the blowdown, what happens? All the salts remain behind. What will they do? They will create more scaling or corrosive tendencies. So you need good chemical treatment chemicals, very strong chemicals, which can monitor which can control very high LSI, very high cycles. And are they available? Yeah, you can talk to one of our consultants, and you'll be shocked to know the kind of limits we can go through.
All right, another questions, an interesting question here. Is BioDart and AquaDart on sale or rental basis? Also, how often is maintenance required for these systems? I think this from Lila.
Look, number one, it is a patent, like I mentioned. It is relatively new. Generally, we avoid selling it to the customer. So it goes as a part of our overall offering. So in the end, let us not forget, we are providing solution to a problem, and BioDart is one part of that. So it requires many other things, the chemicals, the monitoring. If BioDart gives a signal, what to do with that signal, right? If it says, hey, red alert, which I was referring to, that red alert, then what to do? Unless and until we do all these things, we don't get the right solution. So what we have decided as a company is that, hey, there is no point just selling it to a customer and he does not know what to do with that based on what signal it gives. So we generally tend to give it as a part of our offering, as an add-on thing. You might call it a rental or a lease, or it's inbuilt in the program cost. But we avoid selling it because customers might not find it really as useful by just dealing with that as a standalone equipment.
And that will, I mean, that will help them not to really invest in the equipment itself, right? I mean, they don't have to. The only thing that they have, we have to offer them is a holistic way approach.
Yeah, because biodart is a way to solve the problem. If the
Right.
problem is not solved, even if great biodart, it doesn't help. So in the end, it is providing a solution for which you might need. It's like having a good medicine, having a good orthopedic equipment, but thing is, you need a good doctor as well, right? So you might need a water treatment consultant to help you.
Right. So we have actually got tons of questions here, and but these next two questions would be unfortunately our last two questions for today due to time constraint. But don't worry, we will get back to you all and answer your questions through email. And we would welcome also any additional questions you may have. You just have to send us an email. So these last two questions will be with current COVID situation, would it be good NCH can add some form of sanitizer in the cooling towers so that the cooled air that will be pumped out will be sanitized and COVID safe? How would you like to
Uh,
answer that?
I would like to, and then later Elsie can add. Hey, one thing I talked about, I said I'll share a few technologies today, and I did, right? Three of them. Hey, there is another fourth one which we have, which I didn't touch today, just for the sake of the time, which we call it bioexile, right? So the something which you're referring to, the sanitizer, actually we cannot kill all the microorganisms in the water, unfortunately, because they will still be there, and our objective is to keep them within limits. But we have this new patented biodispersant, uh, which can work with the conventional biocides, like say chlorine or bromine or any kind of conventional biocide, which actually in a way is sort of sanitizing your system. Okay, so it is a great hit on Legionella bacteria. We have multiple case studies. We can share them with you as you require, and for all other kinds of microbiological problems. So yeah, in a way, the answer is yeah. We have how old it is? Just around a year back, we got the patent. It is a completely new chemistry out of last 20, 30 decades of microbiological control. That is the only chemistry which is completely new molecule. So Elsie, you might like to add on this. Yeah.
Yeah, I think Manish, you mentioned the most important thing. So clean up your entire cooling water system is the most important thing, rather than just additional chemical. So this BioXL will help you a lot to remove the biofilm. This is the main challenge for the biological control.
And just for the sake of fun, we gave the word as bioexile. Exile means the microbiological organisms, they go in exile. They cannot be seen. So that is like sanitizing, right? So that is the name
Yes.
bioexile. So this particular microbiocide. So yeah, a great invention indeed.
All right. And one more last question would be, can BioDart distinguishes between a biofilm or any scale deposition if it takes place inside the tube?
Yeah, so look, the way it, like I said, we have tried to simulate the system with respect to biofilm. Okay, so for sure, there won't be any scale in the tubing which you saw. It would be only microbiological because there is a laminar water flow there. So scales generally might not. Secondly, there is no heat source there. Scales will form at hot surfaces where the skin temperatures are high and where the solubility product of the salts, because of high temperature, they tend to get exceeded. There is nothing like that in the biodart. So very safely and very clearly, I would say, yeah, this would completely isolate only the biofilm tendency potential and not at all do anything with respect to scaling. Now, can there be some deposit, some fouling, not silt? For that, if you see, there is a very fine mesh strainer, which is in the beginning, before the water goes in. So even though there won't be any fouling.
Yeah, I think Rochelle mentioned this is the last question. Let's add on more answers,
Yes,
information
sure.
for that. So the BioDart, actually, we did a long research study together with the best biofilm lab together in our head office in the United States. So we also designed this special one. It could be simple, but prevent most of the impact as well. And honestly speaking, if the, as Manish mentioned, if inside of the BioDart can build up the scale, definitely we need to check the system condition immediately, because that could be the last place to build up the scale. Then what happened inside the heat changer could be more challenge. So
Right.
any of the impacts from our monitoring, we will pay special attention. So from the design, we start to prevent this kind of things to happen. But if
Yeah,
there any change, we will pay a special attention.
yeah, because if scale could form, LC, what you mean to say is if the scale could form in that bio dart tubing, then before that scale should have formed in all the headers. Forget about the heat exchangers in the cooling
Right.
tower. Everywhere you would have been seen white or yellowish scales. So it won't happen.
Thank you. Well, that concludes our question and answer session here today. Manish would like to say thank you, and Elsie.
Yeah, thanks everyone for taking this time out. Look, this is just to create some awareness. We look forward to seeing some of you, meeting some of you, and helping see how we can address your problems and help you achieve those goals. Thanks for joining from my side. Yeah.
Thank you everybody for your time.
And of course, thank you, Manish, for sharing your insights today. And thank you, everyone who attended today and for your questions. By the way, we will be happy to share you the recorded video of this presentation. Do just send us an email request and we will share it, revert it back to you with the link. Also, kindly spend a few minutes to fill a post-survey form, and you will be receiving an e-certificate and a modest gift as a token of our sincere thanks for your valuable time. Lastly, I would like to invite you everyone to register for our Day 5, which will be on July 10, the same time. If you want to see more about our technologies, such as BioDart, AquaDart, Handycam, so please register, and if you have not done yet. This has been your host, Rochelle Mendoza, for the NCH MainTRAIN webinar series. Thank you, and you all keep safe and you have a good day. Thank you.
Thanks everyone. Thanks. Bye.
Bye bye. Keep safe.
Bye.